We're good, yes, to go get started. All right, well, I appreciate everybody coming in here for this. I know that we stand between you and happy hour, so thank you for coming. Anyway, I kind of want to, the topic of today's discussion is not going to be around so much technology because as you can see out there, there's plenty of technology providers. There's a lot of different instrument companies and vendors and services around it. What I want to really talk about is more of the methodology or the process of aggregating data and what I believe should be considered whenever you're building an ESG or environmental management program. And so, yeah, this is a little bit about me. I founded this company in 2010. Since then, we've obviously grown. We've received some equity partners, and we've made a series of investments and really trying to solve the solution, environmental measurement, how to aggregate data, how to account for that data, and then really what are the methodologies around that, especially as these regulations kind of evolve and move forward. So in the E&P industry and I mean, other industries, not just exclusively E&P, but the biggest problem is the aggregation of data, especially around disparate sets. You know, how do you craft a holistic the sort of impression of all of your assets when you have all of these signals coming in from very disparate sets? And so that's a big challenge. And then how do you synthesize that data in a constructive manner to where you could use it for sustainability reports or for emissions inventories or for things of that nature. But really to look at mechanical integrity issues, look at vulnerabilities in your system, where you can apply change, what makes the most sense and make those kind of decisions. And so, you know, I kind of looked at this as there are no whole truths, all truths are half truths. It's trying to treat them as whole truths that plays the devil. That's really true. I mean, there's not going to be any sort of technology or instrument that's a providential device. It's not going to give you everything that you need to know about your climate performance on site. So what that takes is sort of a vertically integrated suite of measurement practices and methodologies in order to properly contextualize the data that you're getting to tell the whole truth instead of just a half truth. So the way we kind of look at it is the journey begins with asset grade data. And what is asset grade data? I mean, that's going to be different types of process intelligence and automation from your SCADA system. It's going to be site-specific process modeling, equation of state type models, ProMax, HISYS, BMG SIM, continuous monitoring and detection systems, and I kind of bucket these all together, point source, fence line, optical, remote sensing. And one of the things I kind of want to point out with the continuous monitoring and detection, you know, there's a lot of different technologies out there that can do a lot of different things. And not one of them is necessarily better or worse than the other. They're all valid. They all can generate a valid signal. It's just how do you interpret that signal and what you do with that data that really determines its value. And that's kind of one of the things that I want to impress. Is like, I don't think that there's a silver bullet. And I don't think anyone should even look for a silver bullet. We need to look for signals from all across your operations to help drive value. And this is something I've kind of thought about is more of a philosophy than really an application at this point, but community data acquisition and crowdsourcing. So I think about Waze, you know, how valuable Waze is, and you can kind of see the vulnerabilities ahead of you on the interstate. I kind of think of leveraging your community within your organization much in the same way. Empower them with applications and things that can help them continually monitor a system, whatever they're in charge of, whether it be an operator or a mechanic. You know, what are tools that you can give your employees that can generate environmental signals that tell something about your operation? So what I'm proposing here is thinking really creatively about the way that you apply some of these systems and what the value that can be received from them. As we also, the next step in this ecosystem, the kind of the way we look at it is compulsory environmental compliance programs. So one of the things that's frustrating that I've noticed is that a lot of people separate environmental compliance from ESG. And the E part of ESG, compliance is a big component of that. And you see these groups kind of separate out within these organizations, when I think that there's a ton of value to be had within your compulsory programs that can ultimately help your sustainability reports or your carbon differentiation or your commodity differentiation or whatever you're trying to accomplish, leveraging these. An example of that is an emissions performance test. If you're using FTIR, you can gain more insights into your emissions profile than just a criteria pollutant test. You can get methane, you can get calculated carbon or your methane slip, carbon dioxide, and so forth. Leak detection repair program. So this is more of a qualitative data analysis, looking for trends on leaking components. What do you see in your inventory that's consistent? What can you cycle out of your inventory? And then any sort of different samples. One of the things you can also do to supercharge your LDAR program is to lower detection thresholds to what I call ESG levels. So if you are bound by 500 ppm methane, for example, if you just were to lower that in your ESG program to claim anything above background, then that provides you with more analytics around the lower leakers. It's more of a voluntary scenario, but you're gaining more intel into the operations of your system. And then also combined with bagging and sampling activities, trying to understand leak rates, actual leak rates versus AP42 factors, subpart W factors, and so forth. So, really highlighting, taking these compulsory environmental programs and supercharging them in a way that you can get more data from it. Flare efficiency monitoring. I mean, now there's technology available that allows you to monitor flare DRE in real time. And so if you're concerned about what your DRE actually is, what the output is in terms of your methane slippage and so forth, and then applying some sort of artificial intelligence to it to tell you what the optimal metric ratio for that flare needs to be. That's another way to kind of kill two birds with one stone, because you have your optimization piece of it, then you also have your 60.18 compliance if you're trying to use it for that. And then waste gas to power. I mean, this is kind of taking the inefficiencies that are identified in the system and then doing something that with that gas that gives you a better outcome, whether that be taking a flare out of service, putting a generator in, selling it back to the grid, something of that nature. And so really, this is kind of at the heart of what sort of the theory or the process that underpins our thinking here on this was developed by Professor W. Forrester. And he's kind of a hero of mine because he grew up on a farm in Nebraska. They were poor, didn't have electricity. When he was 8, he developed he built a wind turbine out of car parts and supplied electricity to his farm. And he went on to get an electrical engineering degree from Nebraska. And then he went out into the workforce and he was an applications guy. So he was out there interacting with the physical world and making change. And then he later took what he learned in sort of the workforce back to MIT, where he furthered his education, eventually became a professor. And he has a long list of accolades. I mean, he is the father of what's known as system dynamics. He was the architect behind the servo mechanisms on for the early warning detection systems during the Cold War. The guy's brilliant, but one of the things, the reason why I follow him is because he was an applications guy. So he wasn't mired in theory. He was actually out in the world building and integrating these systems. And so I think that his methodology has a lot of application here with what we're trying to do with ESG. So this is kind of a systems dynamic model, kind of overly simplified. But if you think about asset grade data and the action items and the things that sort of go into that model, if you find a problem, then what is the thought process in dealing with that problem to make sure that it doesn't show back up again, that you resolve it, and then moreover that you actually learn from it. And so this is really briefly identify the problem. I want to mitigate carbon, develop a dynamic hypothesis that explains it all. This is very central to Forrester's models or his processes. He believed that if you're going to understand in order to understand the problem, you have to model it first. So can you reproduce that problem in a simulation? And what that does is that takes out lesser causes, and that brings you to the more central cause of what's going on. And then you evaluate the measurements and signals. This could come from continuous emissions monitoring systems. This can come from engine emissions. Any type of signals that are attributed to that problem, you can ingest and then look at how it compares to the model. Develop a plan. Solutions that may seem less effective at first glance may generate meaningful results, and then of course on to implementation. And so there's a couple of things here where this model has been put into practice in my career. Is we had this one LDAR project where the facilities that we monitored had some pretty consistent leaks across the facility. So we saw them coming from the same thing at every facility, and what it was a pneumatic tubing insert that went into a controller. And at that union, at that interface, in literally every one of these facilities, there was a leak at that union. And we tighten it, we inform the repair crews, they go, we tighten it, no resolution. And so we applied kind of a root cause analysis following this model. And what we ended up determining was that the reason why it was leaking in every instance is they were using swedge lock nuts and Parker barrels. And so you did not have like-in-kind union on the pneumatic devices. And they found out that their contractor, that's what they were doing. They had a bucket of Parker fittings and they had swedge lock nuts and they were just putting this stuff together. And so we were able to resolve that by just simply using like-in-kind materials, manufacturing the facilities as they're supposed to be manufactured, and then voila, that leak is gone. And then we can track that, we can learn from that, and then they know now to watch out for that particular thing. The other instance of the same customer, we noticed a certain type of block valve at every facility that would leak. It didn't matter what facility, if there was that valve, it was going to be leaking. And what it was is, again, we applied the same kind of model to it to resolve the problems, and we found out that there was some very pronounced casting marks on the valve, and it was a cheap valve. And so it was actually leaking out of the casting on it. That the casting didn't seal the chamber good enough. So this model has application across asset and operating integrity groups, environmental groups, safety groups, and I've seen it kind of play out in real time. So we've talked about sort of the asset grade, the sort of SIMS instrumentation and the process monitoring, but then there's also the macro view perspective. And what I call macro view is any sort of big picture kind of view, whether it's drone surveys, manned aircraft, geostationary satellites, or low Earth orbit satellites. And I put the Death Star as so in case you didn't catch it, but so you know, this is kind of interesting, right? Because this to me is a screening mechanism. This is a way to screen. And a lot of people look at these again as silver bullets. Is the flyover every month going to save all my? Is going to save me time and money? Is it going to solve my problems? Well, I don't know, but there are some limitations here. But in a systems dynamics model, all of these are signals that you're pulling from your operations. And again, you don't want to ignore any signal in a system in a system that can that has a lot of moving pieces. You want to be able to pull in as much data as you possibly can. And so if you take the system dynamic approach and you sort of start layering the asset grade data with the macro generated signals, you kind of create a feedback loop or an action loop, as you go through here using any number of these macro sort of view instruments. Where is the problem physically and temporally? That's a challenge with any of these instruments because you're not getting continuous revisitation. With aerial surveys, they're intermittent. The interesting thing about satellites, for example, the low Earth observation satellites or the LEO satellites, they're humming around the Earth 16 times a day. So you get a really good frequency of visitation for us from a small set, and that's really important. If you can get a good minimum detectable threshold, then this is your kind of your best screening option, I believe. These are costly and they're temporally limited. It doesn't mean they don't drive value. It just means that there's some limitations there. But the idea is to find where is the problem, identification of primary risk, and then you move over into how bad the problem is. And this is where you use systems dynamic model and AGD synthesis to look for measure, model, analyze, and then this actually quantifies the risk. How big is that risk? And then hopefully you fix the problem. And then all of these things become a qualifying agent for that problem. So for example, if you find some issue here on a facility, you take action and then you fix it, then you can now use these systems to qualify that. Was that reduction or was that real, or do we need to revisit it? Is it systemic? Or are there other things that this system is telling us that we need to look for? But we kind of see this as a constant feedback loop. And so there's a couple key things that, number one, in order for this system to work properly, it has to be evergreen. So you have to be able to address change at any given moment. And so that's a problem. The other problem is the reception of signals that are of known quality. Is this data reliable? How do we feel about it? Can we weigh it into this system or not? So you have to understand the quality of your data. Adapt to physical change, economic limitations, and operational intervention. That's another problem that I've seen in the oil and gas industry. When commodity prices are high, compressors are being set, they're being well maintained, everything's running smooth, and then the minute that commodity prices drop to negative $37 a barrel, then people, staff is reduced. You don't have frequency of visit out these sites, and then they start to degrade, and then the oil field likes to use the term run to failure. And then that's where you're not being able to adapt to the economic changes to a level that's appropriate to what you're trying to accomplish. So all of these things need to be taken into consideration whenever you're building like a systems dynamic model. And then of course using feedback and logic to improve. And this is where I think is real critical at this point. And so with that is where you use neural networks. So in the way that this works is you take your system dynamic action model, whether that be an asset grade system model, or if it would be a macro or a combination of both. But the idea is to take data of known quality that's feeding these systems and apply a neural knowledge network to it, which can help you, drive change effectively. So this is interesting. We have a satellite venture. It's a partnership with the University of Florida, and they have a methane satellite that actually has two channels. It has a visible channel and a methane channel. And we were up there or over in Florida 3 weeks ago, and I was kind of chatting with the guys, and they had a whole group form that was doing object recognition. And so I kind of asked them about it. What are you trying to accomplish here? And they said, well, we can now use we can teach these satellites the difference between a compressor station and a car. And I said, really? And he said, yes, but it's only as good as the information that you put into it. It's only as good as what you teach it. And so it's really important that that data is quality and it's well scrutinized before it enters into an AI system. And I don't know, for those of you that don't know, but a neural knowledge network attempts to mimic the human brain. And so they basically view this as a child. So what are you going to teach a child? And the quality of the education determines, how good of a student they are, and then obviously what the output would ultimately become. And so that's the ultimate goal with AI, or what it hinges upon is the quality of information. And I think that that kind of plays out even with like Bing AI and ChatGPT. I mean, you see like it's using a reservoir of social media data in there to make some sort of analysis of humans, and it's really garbled and dysfunctional. And that's because the data that's being ingested is of unknown quality. And so that's really the goal here. And then what's the benefits? Well, you have process optimization. I mean, I put that at the top. I mean, if you're learning from your mistakes and you're improving the system, then you're going to optimize your process. You move into predictive monitoring, waste minimization, object recognition, which I kind of explained earlier. Inventory improvement, and what I mean by inventory improvement is on your GHG inventories. Having some methodology that's underpinning your program is important in order to understand are my inventory, is the quality of my data improving through inventory, and am I able to meet, what are realistic reductions? That's another thing. Like over the past 10 years, you've heard companies talk about by 2050 they're going to be net zero. They're going to reduce their emissions by 30%. But is that realistic? I mean, are you making a claim that is realistic or not? And so that's kind of another feature of the system. And then investor relations, public perception, image, access to capital, and access to markets. Those are all residual benefits of process optimization, system dynamics as well. So I don't know where I am on time. Ooh. Anyway, that's kind of my presentation. Like I said, it's not about the technology per se, and it's more about the theories and sort of the applications and methodologies to sort of aggregate this data and layer this data and be able to publish it with confidence, I guess. So, anybody have any questions? No.
What's something you wish you saw more operators do? Like a best practice that you think is cost effective, that you wish you could just wave a magic wand and have every operator kind of take on it?
And that's tough. I mean, it depends on what you're trying to accomplish. Like on the engine side of things, I mean, it's catalyst management. Managing your catalyst, keeping your destruction and removal efficiency of your components, at a very high level. See a lot of issues with air and fuel ratio control systems being bypassed. And a lot of that is just lack of oversight by the operator onto their vendors. Most of that stuff is written in the contract that they shouldn't do, but it happens. That's an annoyance. One of the things that we've done is tackle tanks, and the reason, I've been in oil and gas for 20 years, and thief hatches have always been the bane of our existence, right? And it occurred to me one time. I used to work for ConocoPhillips, and I was doing an OGI survey on about 115 facilities in Louisiana, and I was tracking each one of them and the intel that I was getting from it, and 95% of them leaked. And some of it was due to lack of maintenance. Most of it was due to oxidation. And so I remember coming out of the field thinking, why isn't anybody doing anything about this? Because it's obvious that you have dissimilar metals in this environment. They oxidize the minute you clean them, and that oxidation creates voids and pits, and which further degrades the integrity. So what we've done here recently is we've built a fully composite thief hatch. It's made of an anti-static aerospace grade composite, and the theory behind it was remove all of the dissimilar metals and the alloys from the inside, from the seal surface, number one, because that was something we saw over and over again. is that oxidation, and then all of a sudden you have these fissures. And then I don't care how good your seal is at that point, it doesn't have a good sealing surface, right? So that's one of the things that we've addressed. And I think just because if you were to ask me, like, what do you need to do to these tanks, or what do you need to do to your operations to improve them? I would say feed hatch management. I mean, 100%. I mean, because that is like low-hanging fruit for agencies and NGOs. I mean, that's no brainer. I mean, they can look at a tank and see, or a hatch and see that it's open, and they know to start reporting because it's going to be a show. So that those are the things that we're trying to address. Another thing that I think is kind of a limitation too is that, as I mentioned earlier, there's room for each one of these monitoring technologies. There's room for it across the board. It just depends on how you use it and how committed you are to using it. And that's really a frustration to me is that you see a lot of pilot programs and a lot of demos. A lot of folks have been doing this for 3 years. They've been demoing. And it's like, well, don't let perfect be the enemy of good. I mean, at some point, you're going to have to say, look, this is not perfect, but we can get something out of it, something that's useful, and committing to doing that, committing to delivery. And so I think that's kind of annoyance, is a lack of commitment, of just saying, this is good enough, and we just need to commit to it and make it as perfect as we can, and know that technology is going to change and it's going to evolve, and then to create a program that adapts to that change too. That's a new technology adopter, to bring it in and cycle it out. So to me, it's an evergreen process. It's continually looking, but I feel like a lot of times people have the sort of the iPhone syndrome. They get an iPhone and then the new model comes out and they feel pressure to get the new model, even though the other phone is perfectly fine. I mean, I think that's kind of the same thing, that we succumb to. So it's just commitment, that's the thing at the field level, and just so. Yeah, I mean, those are my observations. Sometimes what I know is like simple fixes too, and that's what we try to identify. For the longest time in our emissions testing program, we identified methane slip as being a problem in the stacks. And then when we started putting some of our optical equipment out there deployed at the same time as we were doing emissions tests, we saw that trace methane, kind of in that stream. And what we noticed is that whenever it's colder outside, you have more methane slip, especially in like the western states, and we have snowfall. And what's happening is all that heat is being sucked out of that catalyst and sucked out of the combustion chamber. There's not enough heat contained there to destroy all the methane bonds. And it's really, literally, the easy fix to that is just wrapping your system with insulation. Just wrap the exhaust with insulation, and you almost have 100% VRE of methane. It's just simple stuff like that, right? I mean, those are the kind of signals that I'm talking about in this model of looking for that can drive value, and just help your operations. And they can be little changes. They don't have to be aggressive changes or big capital projects either.
Thank you, that's helpful.
So you're talking about models eliminating the lesser causes and the real causes of erosion. That totally get that, but that also makes you susceptible to, if you have any flawed assumptions with those tangible, causes, that can give you wildly skewed results. So how do your models address the risk of bad data coming in, or a bad assumption or something?
Well, I think it's all about, I think you need to focus on one problem at a time. And in a facility, for example, it may be on a parent system or a subordinate system. And you're focusing on that. What's the problem? What are we seeing in this system? Forget about whatever's going around outside of that. What are we seeing in this? And really focus your analysis. And that way you limit propagation of error, because you're not having to pull in so many different data points to analyze it. And then what you can do from there is just build upon that. Yeah, I mean, so I, I'm not promoting anything. I don't get any commission off the sale of his book, but I suggest you read Principles of Systems, and he's dead, by the way. So he just died a few years ago, actually, like 98. I mean, he was, but he Principles of Systems. He explains he has what's called a dynamo model, and I mean, it's a whole. I mean, I'm probably 3/4 of the way through that book. So, but yeah, if you read about the way he goes about systems, he tries to limit propagation of error through analysis. So, yeah, I mean, and that's been kind of a theme, like what we've always tried to avoid whenever we're looking at developing sample systems and things, or measurement systems, is how can you get the highest value signal without error propagation, like pulling in so many different data points. Like that's one of the things that about point source monitors, right? I mean, they are very sensitive, but the problem with them is they're subject to wind flux and direction and parametric pressure and so many different things. And so as you're starting to build out these dispersion models, you're having to pull in all these sources of data, and you don't know about the quality of all that data. And they could carry a propagation of error with them, any one variable that could throw off the entire result. And so that's why minimizing error or the propagation of error is important. Does that address the question?
Yeah, I think so. It's more of a philosophical question.
Yeah, no, I mean, it's a good question. I mean, so for me, it's like, there's a lot of noise around certifications and guidelines and EPA regulations. But what I've kind of seen is like a lack of a methodology. Like how do you, what is the program that's fueling your system? And does it have an academic basis? Does it have like a rationale? And to me, that's what's very important about any signal that you're receiving from the field is what are your processes in ensuring that data is of known quality, and how are you extracting value from it? And so to me, that requires a very, to me, I think the systems dynamic methodology applies to that. So. That's good. Any more questions? All right.
Thank you.
Yeah, thank you. Yeah, I'm serious, man. I read it, most of it over Christmas.
That was an oxy. You came and did a presentation a long time ago.
Yeah.
It's just a no-brainer.
Oh, that's
We have to do a consulting run. It's now that variety of clients that we do.
okay.
Using Encino, it's not something I directly,
Right.
but it's something.
Well, I appreciate that. I think it's so much.
Yeah, that's always do good. Hey, just send me a copy of this.
Yes, yeah. I can.
Definitely, I was gonna ask you.
Yeah, let me see.
Make a statistic of the great resignations. I got cards and contact.
Hey. A refugee.
Yeah. I wasn't planning on changing or moving, but Terracon had some cool stuff going on.
Yeah. That's cool, yeah.
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 I'm gonna get a photo of the book so that I think, or
Dude.
to try to read it, or at least ask ChatGPT to summarize it.
Yeah, no, it's
When it comes out, there's something about you.
yeah.
Whatever the world quantum C is gonna be.
Rooftop, I think I know that's over. Banking days. Cool.
Yeah.
You mentioned, developing a deposit rebates. Is that within Encino?
Yeah, so,
Actually, one of our biggest issues.
Yep.
We actually just started when we get our new ones, we'll like spray a clear lacquer on it. Yeah, we don't know if it works yet. We just started doing it. So that was one of the things we're gonna try and see if it'll slow it down or switch it down.
well, so what we did is, in our example, they have a stainless model, but it's mainly. And so with me, it's like, that's your line, I'm stopping here, and then at least you guys been picked up. So, our price point is
A couple of years ago, Only like this calendar.
Right, right. Yeah. Exactly, exactly. And so one we came up with is that a private one after that. And we also have an integrated sensor. And so, yeah, I mean, we've eliminated.
What kind of sensor is it? It's closed status or it's like?
It's a.
Yeah.
It'll say, I think it's just has it doesn't have a pump. It's just detecting the thread.
Okay,
And giving you a call.
okay.
So.
So if that changes, you know.
Yeah.
He patch up.
Like it's Belgian, no, it's Belgian, likely, I mean, usually like, is that a feedback failure or is that a process? You know, those are the kind of things that I try to
Too much power.
understand what truly is the problem, instead of just acting.
So we try reading.
Yeah, you just keep addressing an issue, and never patch it up. More facility, build, we are well.
Yep.
Which I would say.
I was just looking at your book, copy of it, took a picture of the publisher page.
Yeah, I think it's very nice.
The publisher page, so I could see who the.
Oh, yeah.
It's hard to find, 'cause sometimes older academic textbooks are,
Yeah,
it can be hard to find. It's like, exactly, I got a picture of that.
dude, and I don't know, if you like geek out to stuff like this, like I do, man, this guy, you need to, this guy really had a remarkable life. I mean, the impact that he made just on everyday, systems
Yeah.
is amazing. And I feel like, technology is kind of, I think the technology has sort of outpaced the foundational sort of architecture. It's like, it's always grasping at the next new thing or whatever. There's no like methodology. And that's what I think about like carbon management. You have to have some sort of logic
Yeah.
that underpins your program.
Yeah.
You can't just sit here and look for something that's gonna solve all your problems either. A logical approach.
I feel like you just described all of like the startup world in tech, like,
Yeah.
we're gonna move fast and break things and disrupt everything, and like, wait, how many problems have you been trying to solve? And how does it help anybody?
Exactly.
You know?
And look at the way, tech is treated too. I mean, a VC might know 10 companies knowing that maybe one of them will actually make it. So it's like, obviously.
Two will break even and seven.
That's right.
Yeah.
That's right. Or you'll have a Theranos.
Yeah,
Something like
or
that.
that.
So it's like, yeah, being nimble and moving fast is great, but at the same time, you have to have some sort of like logic behind it. There has to be some plan.
Yeah.
And that's really what I'm, the disparity in the marketplace is like, these people are just reaching for the next test or the next thing. It's like, let's step back. You guys have a drilling and development plan that you execute perfectly. There's no reason why you can't take that same. There's no reason why you can't take that same level of commitment and go stick it over into this and solve the same problem. It's just that you're not committed and you're not as willing to do it. And you're not putting in the foundation of elements that need to be there. In order to make it successful.
For sure. Well, I was asking about the model stuff because I've done a lot of financial model.
Oh, yeah.
And it's like, I can build this beautiful model, but it's garbage in, garbage out. It's like, I can make it say anything you want. You want your business to be $1 billion in 5 years? Let's do this. Yeah, I can tweak a few things and it all looks good.
Yeah.
But it's still,
Bullshit.
yes, right. Yeah, exactly. And so it's like, if you don't, and a lot of times you can't even see that because you believe your own BS.
Right.
You get anchored to these numbers that aren't real, so it's like, how do you prevent those
Yeah.
assumptions from like.
Permeate. Yeah. Yeah, that's the thing, is like limiting your assumptions is key. I mean, obviously, in the absence of a measurement, you need some pretty ironclad data, and you have to have justification for using that data too.
Yeah,
To me, that's important, as long as you're documenting all the steps.
yeah.
So,
Well, cool. Nice job.
yeah, well, I mean, was it okay?
Yeah, good job.
Thank you.
Hey, Matt, I'm Scott McCurdy. I'm with Encino as well.
Oh, Matt
So,
Starks.
nice to meet you.
You're looking at one of our cameras, aren't you?
Yeah.
Yeah.
Here's
Oh, yeah. Oh, here's it.
He's the head,
Hi.
he's the head dude.
Right on.
Yeah.
Yeah, I'm probably gonna bring you guys into to field agents, measure some well emission data here in like a month or two.
Okay,
Basically, we're plugging wells to get carbon credits.
okay.
So until I can afford a camera. Bring it on.
Sure. How are you thinking about doing that? Like so much time before, so much time after? And then just, basically extrapolate that over the remaining, what is it? There's like a, required timeline to plug the well. If you do it early, you get basically credit for the savings over that time. That's how I generally understand that. Right?
Not quite, if there, the additionality is the word, basically is like, if you have no other requirement to plug the well, then it's additional, and then you get credits, so if you're like reducing, methane emissions, they were X and now they're 0, and the difference is X extrapolated over 5 years, and then that's how much methane emissions.
Sure.
That's what you get credits for.
Sure.
So the bigger the emissions for. But if you were already supposed to plug that well, then it's just compliance. It's compliance, yeah, so you don't get credit for it.
Now, do you have to, I mean, I know carbon credits is kind of the Wild West right now, but do you have a requirement to do like come back every year and just ensure that it's still 0? And then how do they regulate, like, you don't go back in that well?
Those are a lot of good questions, and we're all gonna find out the answer to those in about 3 weeks. So the American Carbon Registry is publishing, they're gonna be the first ones to publish a methodology related to plugging oil and gas wells.
Okay.
At least of the 4 big 4.
Yeah.
Registries.
Okay.
And that's coming out in about 2 or 3
How was it?
weeks. I just learned that today. I've been waiting for it for months. 2 weeks, 3 weeks, maybe, probably 5 weeks or something. But there are some smaller registries that are lesser known, but are like maybe more focused on the oil and gas industry.
Okay.
And so they all have kind of.
Oh, sure.
And so.
Yeah, I met him.
Really know the answer.
He's been Oxford.
Yeah, but we're all kind of figuring.
I actually gave him a presentation back
Yeah,
in
it
15.
seems like a great opportunity.
Yeah, I knew I'd seen him before.
Yeah.
Yeah, he
It
said,
should be a great way to
When
Visually,
popped up the Death Star.
demonstrate
Yeah,
that.
Yeah.
So,
Yeah.
With the, they're actually huge factor. Great. I was like, okay, good.
Last year.
yeah.
okay.
I mean, done it first.
Yeah.
So no,
Okay.
his reaction.
Oh, yeah.
was actually positive.
Well, this guy gave me his card. He wants to see that.
Who was this one?
Sequitur.
Well,
Need to
oh,
give you
I
his
feel
card.
like I'm in a team meeting here.
We're just monitoring.
You can't leave.
Here.
Hey, you got the benefit of like the room afterwards. Everybody else had to run out.
Right.
That's correct, right? Yeah, I should have actually gone through that presentation to make sure I could meet the 40 minutes on it. But, thank you.
I told that some earlier, if you knew that it would be in sponsor, you had access to like who attended what session.
Hey.
This kind of, it's.
He says they're so fat on the seat, that's so bad right now they're putting lacquer. Try to see a light out conversation. What's your name? They're like, they're putting dry on, but I don't know if the baby see.
Salad that should. Well, I'm gonna go upstairs.
Okay, all right. Sound good?
Yeah, we'll see you down
Yeah.
Okay, and this.
Yes, we're done.
Thank you.
Thank you.
Hey, you guys mind if I keep going and I'll.
Yeah, I got shut all that down. That sounds good.